OBKB, we're looking at theoretical probability. So what is the mathematical way to work out, without actually doing an experiment or trial, which we will do, what are the possibilities that we could get? So tossing a coin, rolling a die, which is one die, two dice, or spinning a spinner. We can find that out through experiment. The outcome, that's the word we use for the possible result of the experiment. So like rolling a 5 or a coin showing one of its two sides. An event can either be one thing, a single outcome, I rolled a 3, or an event can be a collection of outcomes. You keep rolling, and that you do all that as one event. The probability of an event is between 0 and 1, or if you want to think about it, money from 0 cents to 100 cents. Kind of 100% possibility, that's 1. Absolutely certain, as we saw in our last section. To represent the chance of the event occurring, the probability of the event occurring, if all outcomes are equally likely, is the number of outcomes where the event occurs and the total number of outcomes, like how many possibilities there are, and we'll look at that down below. Probability is written as a fraction. It can be written as a decimal, and it can be written as a percentage. You might have heard this if there's a 50% chance of rain. That's the probability that it will rain. Okay, the sample space is everything that's possible in the experiment. In some experiments, like the coin, you only have 2 possibilities, heads and tails. That's your sample space. And we write this as the probability, and then in brackets, of what we're looking for, to mean that the probability of the spinner will show green. And we'll look at other ways to do that. So remember, we've got an even chance, if it's right on 50%, or 1/2, or 0.5, however we say it. If this is absolutely an absolute certainty, then that is, another way of saying that is 100%. And if it's impossible, you've got 0 chance of that happening. Let's have a look. So we've got a 6-sided die, and we know our sample set on the 6-sided die is going to be, one side shows a 1, one side shows a 2, 3, 4, 5, and 6. And with sample sets, we like to put in these squiggly brackets or braces, and that shows that that's a sample space, rather, a sample space. So we're looking for the probability of rolling a 3, and we want to give our answer as a fraction. So I'm going to put in here what I'm looking for, the probability of what in brackets? That's a 3. And if I look, there's only one chance, one possible chance out of 6 that that is going to happen. And so my probability is 1/6, and that is already represented as a fraction. Now we want the probability of rolling an even number, and we want to give our answer as a decimal. Don't forget to look at how we want to give the answer. So the even numbers here are 2, 4, and 6. So our probability of rolling, I'll put a word in here, even, that's enough, equals, we've got a 3 out of the total of 6 chance, or if you want to reduce that to half, that makes it really easy to see that as a decimal we know that 1/2 is 0.5. Finally, the probability of rolling a number less than 3, doesn't say equal to, less than 3, and this time we want a percentage. So a number less than 3 is 2 and 1. So the probability, and we'll have to write more words here, of less than a 3 is, how many options are there? There's 1 and 2. So there's 2 out of 6, which is equal to the reduced version of 1/3. And we know that that's one of those percentages you just need to remember. That is 33 1/3%. Or you can put that as 33.3 recurring percent. Or, look at my percent signs, honestly. Or if you needed to round it, you could just put it to 33.3. There you go.